We continue with redox and back titration. Now, when we talked about the titration itself, we said that we use an indicator, right? We use an indicator. Now, when you're talking about redox titration, you don't use any indicator. From the word redox, this reaction involves both reduction and oxidation. Okay, both reduction and oxidation. So what we do in this reaction is this. We are going to have a compound that is going to be undergoing reduction and also undergoing oxidation. But for us to be able to understand redox titrations, we need to understand redox reactions. Now, as we have already said, redox reactions are reactions that involve both oxidation and reduction. So we need to know what oxidation is and what reduction is. You can define oxidation in three ways, depending with the number of hydrogens, oxygens, or electrons. So in terms of electrons, you say oxidation is loss of electrons. Okay. When you lose electrons, that is oxidation. So you use oil. Oxidation is loss. In terms of oxygen, when you gain oxygen, that is oxidation. In terms of hydrogen, when you lose hydrogen, that is still oxidation. Reduction is going to be the direct opposite of what I've written here. So when I gain electrons, that is reduction. When I lose oxygen, it's still reduction. And when I gain hydrogen, it is still reduction. Please, it is very important that you understand this, especially this one. For this one and this one, you also need to understand them, but you apply them more later on. But for the electrons, you need to make sure that you understand that. Okay, let's say for example, we've been given, let me write a simple equation. The same water, okay, let's say hydrochloric acid react to sodium hydroxide, and then here let's say it forms, what will be the product? Let someone tell me. Okay, sodium chloride plus water. Now in this reaction, water is a liquid and then sodium chloride is in aqueous. This is also in aqueous, meaning that they are dissolved in water. So this equation that we have here, we can break all the compounds which are in aqueous into ions. Okay. So the hydrochloric acid, we can break it and it will become hydrogen ions plus chloride ions. And then the sodium hydroxide is sodium ions and hydroxide. And then on the product side, also are going to have sodium ions and the chloride ions. Okay. And then water is a liquid, so we cannot break it. So we'll just write it the same way it has been given. You only break things which are in aqueous and also gases. So you can see the sodium can cancel with the sodium here. The chlorine can also cancel with the chlorine there. So what we are going to end up with hydrogen plus hydroxide. And then this is going to form water. Now, when you look at what is on the left hand side and what is on the right hand side, you can determine, this is generally a redox reaction. This reaction involves one one group of atoms is being oxidized, the other group is being reduced like that. But for you to understand, well, I need first to tell you about the rules when you're talking about oxidation reduction reactions. So one thing you need to understand is what we call oxidation numbers. Now, oxidation numbers are basically representing either the electrons which are being gained or lost by the atom, or they are representing the charge of the compound, okay, or just the charge of an element. For example, a neutral a neutral compound has got an oxidation number equal to 0. For example, if I write hydrogen, this is a gas, oxygen, or I write ammonia, or I write, let's say, sulfuric acid. So all these are neutral. You can see they are not charged. Also, just something like sodium without any charge, or chlorine. All these, but chlorine also exists as a diatomic gas. You can also talk about things like aluminium. So all these are going to have an oxidation number of 0 as a sum of oxidation numbers. Now, when you look at charged atoms, let's say, for example, something that is charged, the oxidation number will actually be equal to the charge. For example, if I say I have got aluminium ion, so the oxidation number here is going to be just that same charge. And then let's say I've got a radical like a sulfate. This same charge on top here is going to be its oxidation number. In this case, the oxidation number is going to be -2. We can talk about, say, a phosphate. Its oxidation number is going to be that same number that is on top there. Okay, so those are oxidation numbers when you are looking at the charge of an atom. You should be able also to know the oxidation numbers of atoms in a compound. Now, oxidation numbers of atoms in a compound will just be the group in which they fall. More commonly, the oxidation number of hydrogen you are going to use is going to be like a +1. Oxidation number for oxygen you are going to use is a -2. You just look at the group in which something is. Atoms in group 1, you've got an oxidation number of +1, group 2, +2, group 3, +3, group 4, it can either be positive or -4, depending with how they are reacting. Group 5 is going to be -3, group 6, -2, group 7, -1, group 8 elements, they don't have any oxidation number, is 0. That's because they are noble gases, they are unreactive. Okay. Now, of this which I've written here, we can see oxygen is having a -2, but then there is going to be a little exception. For example, if you are talking about hydrogen peroxide or something like that. Okay, now using what we've written here, let's determine the oxidation numbers of these atoms. Let's say we've been given aluminium. Let me write something very easy first. Let's say we've been given the same sulfate. They underline the sulfur to say determine its oxidation number. The oxidation number of atoms in a compound should add up to the charge. So we're going to say the oxidation number of sulfur, let me say it is X, plus how many oxygens we have. There are 4 oxygens. And you know, each oxygen, the oxidation number is a -2 because oxygen is in group 6. They should add up to the charge, which is -2. Okay. So here we're going to have X minus 8 is equal to -2. We take 8 the other side, so X is going to give us +6. That will be the oxidation number. Same way, let's say we are talking about a phosphate. We want to determine the oxidation number of the P there. So we say the oxidation number of P, let me call it Y, plus we have got 4 oxygens. Each oxygen is a -2. The charge should add up to -3, which is a power. So this is going to be Y minus 8 is equal to -5. I'll take 8 the other side, so it will be 8 minus 5. That will be a +5. Sorry, 8 minus 3. I don't know why I've changed and written a 5. So that is going to give us a +5. When you're talking about the oxidation number of something that is neutral, let's say we are talking about ammonia. like that. Now this is ammonium. Ammonium has a positive charge. Ammonia is like this. Let's say I want to determine the oxidation number of nitrogen. So say the oxidation number of nitrogen, let me call it X, plus we have got three nitrogens and hydrogens. We said each hydrogen has got an oxidation number of positive 1. This should add up to the charge, but this one is not charged, so should add up to 0. This is going to be therefore equal to negative 3. This is going to be the oxidation number of our nitrogen. Basically, this is how you get to find oxidation numbers of compounds. Is this okay? Are we good here? Okay. Now, after you understanding this, now a redox reaction is a reaction that involves both oxidation and reduction. Let's say we've been given iron 2 plus. It reacts with copper, and then you are producing iron and then copper 2 plus. Now, if you look at this equation, you can show the change of oxidation number. So from iron, we are going into iron 2 plus. From copper, you are going into copper 2 plus. Okay. Now iron 2 plus to iron. The iron here does not have any charge, meaning that its oxidation number is going to be a 0. The copper on the other side doesn't have any charge, meaning that its oxidation number is a 0. Now, when you are moving from a charge of positive 2 to a charge of 0, remember we said oxidation is loss. So I can actually even break this one into two equations. So I'm going to say iron 2 plus, and then this is going into just iron which has a charge of 0, and then the copper is going into the copper 2 plus, like that. Okay. Now from here, what you want to make sure is that you need to make sure that electrons, the charges on both sides of the equation are the same. On the product, you have got a charge of 0. On the reactant, you have got a charge of negative 2. So what we are going to do is we are going to add electrons to balance the charge. Now, electrons are negatively charged, so we want to add where there are more positive charges. So we have got positive 2 going into 0. So what number should I remove from 2 for me to get 0? What number should I remove from 2 for me to get 0? Okay, we should remove a 2. Now removing a 2 is the same as adding 2 electrons. So I'm going to add 2 electrons on the reactant. And for this other one, you can see it is moving from a charge of 0 going to a charge of positive 2. Meaning that I'm going to add electrons to this side. Adding electrons is the same as subtracting a 2. So I'm going to add 2 electrons on the product side. And remember we said oxidation is loss. When you see electrons on the product, that means that they've been lost. Okay. So this is the 2 electrons here, meaning that this equation here is what kind of equation? It's an equation showing oxidation. And you know that reduction is gain. Reduction is gain, rig. When you see electrons on the reactant side, just know that electrons are being gained. So this reaction is undergoing reduction. Another way we can explain oxidation and reduction is oxidation is actually an increase in oxidation number. Reduction is a reduction in oxidation number. So you can see for iron going to iron 2 plus going into iron, the oxidation number is changing from positive 2 to 0. So we are reducing oxidation number, so that is reduction. For copper, it's moving from 0 to copper 2 plus. We are increasing oxidation number, so that is what? Oxidation, right? So that is actually how we go about it. Is that okay? Is that okay? Okay. All right. Now, the most important thing that we need to know here is when we are dealing with this, our interest is understanding how to balance redox reactions. Okay. Now, I didn't mention one thing here for this reaction. So, iron 2 plus is undergoing reduction, copper is undergoing oxidation. The compound that undergoes oxidation is known as the reducing agent, also known as the reductant. The compound that undergoes reduction, the compound that undergoes reduction is known as oxidizing agent, also known as the oxidant. Okay. Now, oxidizing agent is a compound that oxidizes other compounds while itself it gets reduced. Same with reducing agent. Reducing agent is an is a compound that reduces other compounds while it undergoes or while itself it gets oxidized. Okay, is that okay? All right. Okay. Now let's go on with how do you balance redox reactions. Okay, so when you are balancing redox reactions, there are actually two methods that you use. One is known as balancing by oxidation number method. The other one is balancing by half reaction method. Now let's start by oxidation number method. Okay, oxidation number method. Now when you're using the number method, it's basically direct, nothing any hard about it. Let's say for example we have been given iron 3 plus, and then say it is reacting with zinc, and then it produces iron and then plus zinc 2 plus. For us to be able to balance this one using oxidation number method, what you do is simply show arrows. Iron 3 plus is going into iron, zinc is going into zinc 2 plus. Now you need to know which equation is undergoing what kind of reaction. which one is being oxidized, which one is being reduced, like that. So from here, the ion, you can see there is a reduction in oxidation number, because the oxidation number for this one here, actually that's what you do. You need to write the oxidation number of all the atoms. So zinc is 0, iron is 0, and then the other ones they've already been given. So can you tell me, moving from a charge of 3 to a charge of 0, is that oxidation or reduction? Very good, reduction. So meaning that the 3 electrons here have been gained. Remember we said reduction is gain. So 3 electrons gained, while on top the oxidation number is increasing. So 2 electrons have been lost. Okay, like that. What you do now from there is that you swap numbers at this point. You are going to multiply this equation. The equation on top, the arrow is showing that 2 electrons have been lost. So multiply this equation by 2. And then this 3 which is down, multiply this other equation by 3. So if we multiply this by 2, the ion, we are going to multiply it by 2. So it becomes 2 iron 3 plus. And then for the zinc, we are multiplying by 3. So that will become 3 zinc. On the product, the iron, we are also multiplying it by 2. So that will be 2 iron. And then the zinc will multiply by 3. So that is going to be 3 zinc 2 plus. Okay. So that is how we go about it. Hope this is okay. Okay. Let me just give one more example. Say we are using aluminium and then it reacts with sulfuric acid. And then this produces, let's say, aluminium sulfate and hydrogen. We want to balance by oxidation number method. The first thing is we need to determine the oxidation number of each atom in this compound. Aluminium already, because it is just an atom alone, meaning that the oxidation number is going to be a 0. Hydrogen here, we know hydrogen, the oxidation number is a positive 1. Oxygen, the oxidation number is a negative 2. So what remains is we need to determine the oxidation number of sulfur. We have got 2 hydrogens, each with a positive 1, and then plus the oxidation number of sulfur, which is X, plus we have got 4 oxygens. Each oxygen is negative 2. This should give us a 0 because that's the charge of sulfuric acid. Okay, so this is going to give us a positive 2 plus X minus 4 being equal to 0. So 2 minus 4, that is going to give us a negative 2. We take the other side, so X is going to give us a positive 2. So that will be the oxidation number of sulfur here. And then we come here. Okay, so this other side, we have got oxygen. Oxygen is still negative 2. Now, aluminium here, the oxidation number is not going to be a 0. Instead, it will be a positive 3 because it is reacted. You go in the group where aluminium is found. Aluminium is found in group 3 of the periodic table. So when it is reacted, that will be its oxidation number. Now the aim is to find the oxidation number of sulfur. The oxidation number of hydrogen here is a 0. To determine the oxidation number of sulfur, we're going to say aluminium, we have got a 3, and then plus. For sulfur, you can see we have got a 3 down there, so meaning that we are going to have 3. Let's say the oxidation number of sulfur is X. and then plus oxygen, we have got 4 and we have got a 3 because it's in bracket, so that is 12. So 12 times negative 2, this should give us a 0. 12 times negative 2, that is a 24. And then 3 plus 24, that is a 27. We'll take 27 the other side, so 3x is going to be able to give us 27, right? And from there, what else are we going to have? We are going to have, we divide both sides by 3 to actually be negative, so that will be negative 6. Negative 6 like that, okay? Now, I didn't just punch properly for the first one, which I wrote. For this one, we have got 2 hydrogens, each with a positive 1, plus a sulfur, then plus we have got 4 oxygen, each with a negative 2, should give us 0. This is a positive 2 plus sulfurs. Let me put x there, plus x. And then minus 8 is equal to 0. So this was supposed to be 2 minus 8, which is a negative 6. And then if we take the other side, it gives us a positive 6, not positive 2. Same with this one, is positive 6 actually, because this was supposed to be 3 minus, you see, that is a minus what? 12 times 2 here, that is a negative 24. So 3 minus 24 is 18. Okay, it was supposed to be negative 18, but we've taken it the other side, so it's positive 18, and then divide by 3, that's a positive 6. Okay, so are we good on determining oxidation numbers? Now we are going to look at those atoms whose oxidation numbers have changed. Which atoms have got oxidation numbers changed? So aluminium is moving from 0 to positive 3, so we're going to show an arrow. And then hydrogen, you can see it has moved from a positive 1 all the way up to a 0. So for hydrogen, moving from positive 1 to 0, that is a reduction. So meaning that 1 electron has been gained, because gain of electrons is reduction. I mean, reduction is gain of electrons. Yeah, that's the same. So 0 for aluminium is from 0 to positive 3. There's an increase in oxidation number, and increase in oxidation number is oxidation. So 3 electrons have been lost. So we are supposed to swap these numbers, so multiply this equation by 1, multiply the equation on top by 3. So if I multiply the equation which is down here by 1, what we are going to have is aluminium, there's a sulfuric acid here, and that is going into aluminium sulfate, and then plus a hydrogen. Now we multiply the second reaction, that one we are multiplying by a 3. Okay, so we are going to put a 3 here. We are supposed to also put a 3 here, like that. Does this make sense? People are quiet today, so I'm going to make sure that the class is short. Does this make sense? We are just multiplying the 3. Oh, I wasn't even supposed to attach this 3 here. Supposed to put it here. We are just following here. This one and this one, we are multiplying by a 3 here. Okay. So when we do this, now we look at our After you finish doing that, now just inspect your equation. Okay, inspect your equation. Aluminium 1, that is okay. We have got 6 hydrogens, that is also okay. 3 sulfur, also 3 sulfur, that is okay. 3 by 4, 12 oxygens, also 12 oxygens, so that is okay. Okay, so that is how we're supposed to go about this one. So that is how you balanced, that's how you balance an equation by oxidation number method. Okay, it is as direct as that. But for this one, I actually forgot something. I didn't write the equation correctly. So there is actually a 2 which has been placed here. If we write the correct formula, it's supposed to have a 2 there. Now, after I multiply by the 3's, you can see this aluminum is not balanced. So after you balance by multiplying, now you balance by inspection. So already there are 2 aluminums on the product. Just come and put a 2 in front here. So also need to balance by inspection after you are done with multiplying with the numbers that you are talking about. Okay, so that is how you go about it. Now, the second method of balancing these guys is balancing by half reaction method. And this is very interesting, and you gain a lot of marks if this one comes, like 8 marks to balance. Okay, so balancing by half reaction method. Let's say the question that we've been given, say we have been given iron 2 plus let's say this guy, and this produces iron 3 plus 2 Cr3 plus. So for this one, you need to make sure that you understand because it has got steps. Step 1 on this method, you always first break your equation into 2 half reactions. So the ion is going to pair up with the ion. So we're going to write ion 2 plus, that goes into ion 3 plus. This one also, it has got a chromium, it will go also with the chromium there. So that's the next thing that you do. Cr2 or 7 2 minus also goes into, oh, so forget about this 2 there, it's not there. It goes into Cr3 plus. So this is step 1, just breaking your equation into 2 half equations. Now step 2 is going to involve us getting to look at our equation, and we are looking at our equation to make sure that we balance atoms. Okay, we need to balance atoms other than oxygen or hydrogen. Hope you've gotten that. Balance atoms other than oxygen or hydrogen. Can see here we only have one ion, so that is okay. But for the second reaction, we have got, on the reactant side, we have got 2 chromium atoms, but on the product we only have 1. So what we are going to do is we are going to balance that. So this will give us ion 2 plus, and that is going to go into ion 3 plus. And then here we are going to have Cr2 or 7 2 minus. So you can see what I've just done here is I've simply put a 2 in front of the chromium to balance the chromium. Remember I said that balance any other atom other than oxygen or hydrogen. So we're not balancing any oxygen here. So I'll be rubbing what is on top. So hope you'll be following. Okay, so now for step 3, okay, so for step 3, now you balance oxygen. Now you balance oxygen by adding water. You balance oxygen by adding water. Now you can see the first equation here doesn't have any water there. Okay, so we just write it the same way it is. But the one which has got, I'm not talking about water anyways. I meant it doesn't have any oxygen. Okay, so now for the equation that has got oxygen, you can see there are 7 oxygens on the reactant. You don't have any oxygen on the product. You balance oxygen by adding water. Because you have got 7 oxygens, you are going to add 7 water molecules. In the 7 water molecules, you have got 7 oxygens, which will balance with the 7 oxygens here. So that is how you go about that. So we have balanced oxygen. That is step 4. Now, as we were balancing oxygen, we actually introduced the hydrogen. That was step 3. So in step 4, the ion will still write it the same way it is. Nothing is changing for it. So now we are going to balance the hydrogens that we have introduced. And we balance we balance hydrogen by adding hydrogen ions. So if you look at the difference between hydrogens, on the product you have got 7 hydrogen ions. Now we can't get you. Okay, so on the product you have got 14 hydrogen. So add 14 hydrogen ions. You balance by adding hydrogen ions on the other side. Okay, that is step 4. So at this point, I've balanced all atoms. I balanced first atoms other than oxygen or hydrogen, and then I balanced oxygen, and then I balanced hydrogen. Now, step 5 will be now balancing charge. Now, how do you balance charge? If you look at the first reaction, the charge on the reactant is positive 2. The charge on the product is positive 3. For the other reaction, you can see this is 14 hydrogen ions on the reactant, and then you have got also a, a negative 2 charge. So the 14 hydrogen, that is like positive 14 times positive, that is like a positive 14, right? And then we have got a negative 2. So we add that positive 14 and negative 2, which is we are getting this power and then this one, but there is a 14 in front. So that is going to give us a positive 12. And then on the product, the charge, you have got positive 3, but remember there is a 2 in front, so that is going to give us positive 6. Water doesn't have any charge. So for us to balance the charge, what we do is we want to determine which side we are going to add electrons. Now remember what we said, you always add electrons to the side that is bigger, which is having a bigger number. So I'm going to add an electron here, because adding an electron is the same as removing a 1. So you need to remove a 1 there because you want this to be the same as this. So 3 minus 1 will give you a 2. That's what you want. The meaning of that is that for the first half reaction, we are supposed to add 1 electron on the product. For this one, we can see it is positive 12 going into positive 6. So the bigger side is a positive 12. So what you do is that you are going to add 6 electrons here where it's big. Adding 6 electrons is the same as removing a 6. 12 minus 6 will give us a 6. We would have balance. So we're going to add 6 electrons. Remember, we have got 14 hydrogen ions. And then we have got Cr2 O72 minus. And then we have got 2 Cr3 plus. And then we have got 7 water molecules. At this point, we have balanced charges. We have balanced atoms. Basically balanced everything. Step 6 is going to be now we need to balance electrons. Remember, we are adding electrons to balance charges, but now we need to balance electrons. So that will be step 6. To balance electrons, look at this one. First reaction has got only 6 electrons. Second reaction has got, it has got only 1 electron. The second reaction has 6 electrons. Okay, sorry for that. So what I was saying is that the first reaction has got only 1 electron. Okay, the first reaction, all right, sorry for that. The first reaction has got 1 electron on the product. Second reaction has got 6 electrons on the reactant. We need to balance the electrons. So what you do is that you swap the numbers. This 6 multiply this equation by 6. And then this one multiply this equation by 1. So what you are going to have is 6 ion 2 plus. That is going to go into 6 ion 3 plus 6 electrons. And then for the other one, you're multiplying by 1. So it's the same. Just write the same way it is. 6 electrons plus 14 hydrogen ions plus Cr2 O72 minus. And then that goes into 2 Cr3 plus 7 water molecules. Step 7 would just be now the final one. When you reach a point where the electrons are the same on the reactant and on the product, now add the two reactions. Okay, add the two reactions. What you're adding is what is on the reactant side, add with what is on the reactant side of the other one. What is on the product also add with what is on the product of the other one. As you are doing that, you're also cancelling what to appear on the reactant and on the product. So I'm going to have 6 ion 2 plus 6 electrons plus 14 hydrogen ions plus Cr2 O72 minus, and that goes into 6 ion 3 plus 6 electrons plus 2 Cr3 plus 7 water molecules. So this will cancel with this. Okay, so now just write what remains. That is going to be a balanced reaction. This plus this is equal to this, and that. This method we have done here is known as balancing in acidic conditions. We are saying acidic because we have introduced hydrogen ions. The presence of hydrogen ions is what determines whether a solution is acidic or not. So if we are balancing, let's say they told you to balance in basic conditions, you are going to do everything we have done, but then you are going to add step 8. Now step 8 will just be the addition of hydroxide, and that will depend on how many hydrogens do you have. So I've got 14 hydrogens, so I'm going to add 14 hydroxides on the reactant side, and then also add 14 hydroxides on the product side. So the final then would be 6 ion 2 plus. When you add 6 hydroxides and 6 hydrogen ions, you are going to get, sorry, 14. You are going to get 14 water molecules. And then plus Cr2O7 2 minus, and that is going to go into 6 ion 3 plus on the product we've also added 14 hydroxide, and then plus 2 Cr3 plus, then plus 7 water molecules. Now just look at what's appearing both sides. We have got 7 water molecules, so the 7 will cancel with 14. So we are only going to remain with 7 water molecules on the reactant. So the final product will have this, this, and this. If they said balance in basic conditions.